Hello dear students, it's me Vivek sir, and today lecture number 2, chemical reaction and equation. Today we are going to study the characteristic of chemical reaction. The characteristic of chemical reaction means how do we come to know that a chemical reaction has taken place. So we have to learn some of the observations that determines a chemical reaction, and these observations are evolution of gas, formation of precipitate, change in temperature, change in color, change in state. So dear students, one by one we are going to study in detail these observations. Now first, evolution of gas. If there is a evolution of gas has occurred, chemical reaction has taken place. For example, take a conical flask and fill 100 ml of dilute sulfuric acid, and in that also pour some zinc granules. Children, zinc granules mean small pieces of zinc. Add some zinc granules in this flask. After a while, we observe that gas starts diffusing in the conical flask and coming out. This observation shows that there is an evolution of gas. It means there is a chemical reaction. Overall reaction we can write, children: zinc plus sulfuric acid, so zinc sulfate plus hydrogen gas. We know that zinc contains 2+ charge and hydrogen sulfate is the combination of two radical H plus and SO4 2-. So dear students, positive charge always attract negative charge and it forms zinc sulfate and hydrogen gas. But one thing, children, how can we know that without chemical reaction then which gas is evolved? So in order to understand this, we have to learn their observations. We take a burner near this gas. If this gas burns with a pop sound, then this gas will be hydrogen gas. And if this gas extinguishes the burning candle, then this gas will be carbon dioxide gas. Clear, children? Now, our second observation is formation of precipitate. Children, first of all, we have to understand the meaning of precipitate. The word precipitate means an insoluble solid product which produced during a chemical reaction. Clear? It is an insoluble product which produced during a chemical reaction. We can write the definition in such a way that it is a solid product which produced in a solution. It means it is always deposited or float over the solution or at the bottom of the solution. See, we will take two beakers. In first beaker we will take lead nitrate aqueous solution, and in second sodium iodide solution, and mix these beakers with each other. Okay. After a while we found that there is a precipitate of lead iodide is deposited at the bottom of the beaker in the aqueous solution of sodium nitrate. Clear, children? Overall reaction we can write lead nitrate plus sodium oxide, because after combining this we found lead iodide solid product. So lead nitrate is the combination of lead 2+ and NO3-. Sodium iodide is the combination of Na+ and iodine minus. Here positive charge attract negative charge and it forms sodium nitrate solution, and there is an insoluble solid product, so PbI2. Clear, children? Now third observation is change in temperature. If you find little bit or more difference between initial and final temperature, it means chemical reaction has taken place. For example, children, take a beaker and filled with water, and in this beaker we also poured some solid crystal of calcium oxide. After a while, we found that the beaker becomes hot and keep in touch. When we touch, it becomes hot. So overall reaction we can write: when calcium oxide react or dissolve in water, it forms calcium hydroxide. So due to the formation of calcium hydroxide, the beaker becomes hot and heat evolved. Now our fourth observation is change in color. If there is a color changing, children, if color change, it means chemical reaction has taken place. For example, when reddish brown iron react with copper sulfate, which is always found in blue in color. So when iron rod is dipped in blue color of copper sulfate solution, so due to the formation of iron sulfate, the whole solution will be in green. So there is a color change from blue to green. It means chemical reaction has taken place. Second example, when silver react with hydrogen sulfide, and we know that silver always found in silvery color. So due to the formation of silver sulfide, it becomes black. So there is a color change from silvery to black. Chemical reaction has taken place. Now our last observation is change in state. See children, very common example. Suppose take a burning candle, and we know that it is made up of wax. There is a wick which is carbon is present in that. So when wax is burnt in the form of wax candle, then water and carbon dioxide are formed. Water and carbon dioxide formed, and wax is solid, water is liquid, whereas carbon dioxide is gas. So there is a change in state from solid to liquid and liquid to gas. It means chemical reaction has taken place. Clear children? Now see children, our next topic is word equation. Word equation is a chemical reaction expressed in words rather than chemical formula. It means word equations are always expressed in words rather than chemical formula. Means we will not get any chemical compound, atoms, symbol of atoms, molecular formula. We will get only in chemical formula is expressed in words. For example, hydrogen plus oxygen, it forms water. Aluminium, ferric oxide, it forms aluminium oxide and iron. So here the symbol of hydrogen is not given there, the symbol of oxygen is not given there, and the symbol of water and the chemical formula of water is also not given there. Means water always expressed in words. Formula of water, hydrogen, oxygen, these all are expressed in words, neither chemical formula. Now chemical equation children, it is the symbolic representation of chemical reaction in the form of symbol and formula in the chemical reaction. It means when word equation are expressed in symbol and formula, it means there is a chemical equation. Clear children? Once again I repeat, when word equation are expressed in symbol and formulae, it means chemical equation is given there. For example, we can take same example, hydrogen plus oxygen. There is a word equation. See children, this is a word equation because it is given in word equation. Hydrogen, when we write the symbol of hydrogen H2, oxygen O2, we get the formula of H2O. So this is given in chemical equation. Clear children? Now we are going to read balancing of chemical equation. Clear children? Balancing of chemical equation. First children, we have to know that why balanced chemical equation is important. It remind children, in previous classes you have learned that law of conservation of mass, and it states that the total mass of reactant must be equal to the total mass of product. We can also define means in such a way that the total number of atom on reactant must be equal to the total number of atom on product. So how can we balance the chemical equation? See, we have to learn two steps, children, and by following that we can balance the chemical equation easily. See, identify each element found in the equation. First, we have to identify which element is given on both sides, oxygen or oxygen. We have to find if oxygen is given there. We have to find how many atom of oxygen on reactant, how many oxygen atom are given in product. The number of atom of each type atom must be same on each side. Balancing chemical equation state that the number of atom on each side on reactant or product must be same. This is very important, children. This steps is very important. Start the balancing of atom first, which has maximum in number. Means we will balancing those atom first which are given in maximum in number, either reactant or in product. Let's begin how to balance chemical equation. I will take a very simple example, children. First, when aluminium burns in oxygen, it forms aluminium oxide. So I've told you, start balancing of atom first, which has maximum in number. So here oxygen 2, 3, 5. Total number of oxygen is 5. And total number of oxygen is 2 or 1, 3. So oxygen are given in maximum number. So we balance this atom first. Balance oxygen on both sides first. Here oxygen is given in twice, means 2 atom. Here is 3 atom. So there is a problem, children. How can we balance 2 and 3? It means because 2 and 3 are never equal with each other. So we will multiply 2 by 3. 2 3 ja 6, and here 3 we will write 2. 3 2 ja 6. If we multiply on reactant by 3 and in product by 2, then oxygen will be balanced. Let's see. When O2 on reactant, children, on 3 will get 2 3 ja 6, and here we will multiply 2. 3 2 ja 6. So oxygen balance. Now remaining only aluminium. Here total number of aluminium is 4. 2 2 ja 4. Then we will write 4 aluminium. Now you can check, children. 4 aluminium, 3 2 ja 6 oxygen, 2 3 ja 6 oxygen. Clear? Now let's see another example. When magnesium react with nitrogen, it forms magnesium nitride. Now see, children, here magnesium are in 3 number. 3 atom of magnesium, 1 atom magnesium. Magnesium is not balanced. Nitrogen 2. Nitrogen is balanced, but magnesium is not balanced. So children, we will balance the magnesium. Now total number of magnesium is 314, or nitrogen is also 4, children. So if we write, so children, nitrogen is balanced but magnesium is not balanced. There is a 3 magnesium. We can write 3 magnesium. Clear, children? 3 magnesium, 2 nitrogen, 2 nitrogen. Let's see another example. Complex example, children. FeSO4, when it decomposes, it gives Fe2O3 plus SO2 plus SO3. Now see, children, suppose we have to balance this equation. I think there is a problem for you, children, because more product are given there. So don't worry, children. We have to follow only 2 rules. I've already told you. Now count which atom are given in maximum in number. Now we are observing that there is a oxygen in maximum number 3, 2, 5, 5, 3, 8. 8, 4, 12. It means oxygen on both sides are maximum in number. So there are 3, 2, 5, 5, 3, 8, and there is 4. If we multiply by 2, now see children, if we multiply by 2, 4 2 ja 8 oxygen, 3 to 5, 5, 3, 8 oxygen. 2 sulfur, there is 2 sulfur, there is 2 sulfur, and 2 iron, there is 2 iron. So it is chemically balanced.